Okay, everyone. So let's carry on where we left off last time. So our goal is going to be basically that of building an experiment. So the experiment in question, I'm just going to be using something that I ran a few years ago at the Science Museum in London. This was an experiment that was aimed at determining what is the appropriate period to establish eye contact with another person. You know, some people might, when we lock eyes with another person, sometimes we might get a very short glimpse, sometimes we might get a long stare. And both of these things might be uncomfortable. And there's some sweet spot, there's some duration that supposedly people sort of agree is just the right amount of eye contact. So we're going to try building this, which is a relatively straightforward task. And we're going to also try at some point to have something which is relatively short and easy to run, so you can run it on yourself and sort of get your own statistic for what's your personal preferred contact duration. So the way this basically works is we're going to have a stimulus, which is going to be a face of an actress, which is going to be initially looking down, okay, gazing downwards, for a fixed amount of time, which is going to be 500 milliseconds. Then this actress is going to look up for a period of time that can vary between 100 milliseconds and 10 seconds, so for a variable amount of time. And then she's going to look down again for a fixed amount of time, that's 500 milliseconds. So this is basically what's going to happen within a trial. At the end of every trial, we're going to ask the participant to respond whether the period of time in which the actor was looking upwards felt too short or too long with respect to what feels comfortable. Okay, so obviously this is typically in experiments you're not going to have just one trial, but you're going to repeat several trials. Okay, so we're going to, I don't know, repeat this for 40 trials or something like that. Okay, so this is a relatively simple task, but of course, you know, when it then comes again, like we talked about last time, if you actually then, you know, open your MATLAB editor and you know, think, okay, let me just start typing in these things, you're not going to know where to start from, because it's in reality, even though it's simple, there's a lot of little aspects to it. So the way you have to think of this is by breaking it down into small components, and then you just tackle them one at a time. Then you compose these into the big picture, into your full-fledged experiment. So let's start off by talking, however, of just a basic blueprint of an experiment script. So obviously, you know, every experiment is, you know, might be completely different. So you there might some experiments that require very few lines of code. Other experiments are going to require a lot of lines of code, and they're going to be doing very different things. But if you sort of break down all experiments into, like, let's say the basic workflow, you end up with a blueprint which is more or less always the same. You generally always start your script by creating a sort of a clean slate. You basically clear all your variables from your workspace in MATLAB, just to make sure that, you know, you're not overwriting pre-existing things, and you're not going to save them then and get things confused. So you want to start with a clean slate. So the first thing that you generally come across when you're writing an experiment is there's going to be a clear all instruction right at the head of your script. Then generally that's followed with a series of lines that are dedicated to setting up some variables that are going to control your experiment. For example, you know, how many trials are you going to be running, or for example, how many blocks are in your experiment, or how long should you know, certain stimuli, you know, be expected to remain on the screen, and if these are constants, you could set them up at the head of your script. Then Psychtoolbox is a program which is generally used to display stimuli on the screen. So basically what happens is that Psychtoolbox is going to open a window. It's going to open a window on which you can then display things. So there's going to be an instruction in Psychtoolbox in your script which is specifically there to open a window, which then you will eventually close, okay? And in between these two things, is where the action happens in terms of, you know, trials. Okay, so the stimuli that you're presenting, the responses that you're collecting, data logging, and the fact that these trials are repeated over and over again. Okay, so that's the meaning for this loop over here. Okay, so when your trials are over, you close the screen that you opened. And then generally what you do, the last step is going to be something about saving your data, just making sure that it's stored on your disk, and then you can just reload it at some other time and analyze it. Okay, so we said that an experiment generally starts off with a laundry list. Basically, you sort of want to have a handle on what are the key ingredients that make up my recipe, which is, you know, the final product, the final experiment. So let's say one thing that you're probably going to need is, because you're going to be testing, supposedly you would be testing different participants, you want some way of, for example, when you start your experiment, to record the name of the participant, for example, and generally some demographic, you know, variables such as, for example, their age or their gender. So you would like to have, like, for example, in your experiment, some way of requesting this data when you start your experiment. Okay, so that's one thing we want to do. Another thing we need to do is we need to present some stimuli. Okay, so for example, we saw that these stimuli are going to be, well, we could use videos, but in this example here, we're just going to use some still frames. So we need to load some pictures and display them in Psychtoolbox. Okay. So that would be enough, but, you know, generally in an experiment you also have some instructions, like, for example, you know, just a greeting screen that says, "Hi, welcome to the experiment. You're going to be, you know, asked to do this and that, so you should press this or this." Anyway, we might want some text as well, aside some images. So those are two types of visual stimuli that we might need to deal with. We need to consider how events are going to flow in our experiment. So that's another component, another element of our experiment. So remember that we have a trial, right, in which stimuli appear, but they don't just appear all of a sudden. They appear at a certain schedule. You know, there's first this type of stimulus looking downwards for a fixed amount of time. So that's going to be 500 milliseconds from the start of your trial. So we have to be able to control this to make sure that this stimulus appears at the beginning of the trial for 500 milliseconds. We're going to have this other stimulus, which is just looking upwards, for a variable amount of time after this interval has elapsed. All right? And we're going to finish it off with, again, the downward gazing stimuli at the end of this variable interval here. Okay? And then the other event we need to control also is when the subjects can produce a response, okay, which must happen after these stimuli have been presented, you know. So we want to make sure that we're not actually recording responses while the stimuli are on the screen, because that wouldn't make any sense. Okay, so we have to consider these things. We have to consider when things are presented in the trial and for how long they persist in the trial, and also consider the fact that we're not just going to be showing one trial, but we're going to be showing various trials. So that's also something that we have to account for, the fact that there's going to be a repetition. So another element we're going to need is more specifically to control, you know, the responses. So here we talked about, you know, controlling when responses are going to be pulled, when are we actually reading keyboard events. But we need more specifically, you know, for example, some way of determining what key presses, for example, will be allowed, you know, what key presses to expect. So, for example, in this task, as we said, you know, at the end of the trial, we're going to ask the participant to indicate whether this period of time that the actress looked up felt too short or too long, with respect to what feels comfortable. So we're going to need, it's a binary type of choice thing, so we're going to need two key presses for that. So for example, we could say that if the participant presses A, they meant that this period was too short. If they press L, it means that this period was too long. Okay, and let's just make it so no other keys are allowed. So we have to be able to control these things. Another thing we're going to need, another ingredient we're going to need, is to log results. So basically, at the end of each trial, we have to make sure that we're keeping track of what trial was presented, you know, in terms of, in this case, the duration that we were actually presented. So for how long did the upward gaze actually last, you know. We have to know what button was pressed. So we have to keep track of these things, and so we have to figure out how to do that. But with arrays that we already saw, this is going to be, and with matrices, this is going to be relatively simple, because we're basically going to be sort of like populating a sort of a spreadsheet, if you sort of think of it. Finally, another thing that we have to make sure that our script is capable of doing will be that of saving results. So when you're logging data, you're logging it in the sense that you're keeping track of it as long as MATLAB is up and running and you don't clear the workspace. But we have to make sure that these variables that we logged are actually permanently stored on our hard drive, so we can then pick it up at some later stage and analyze the data. All right, so let's start off by just tackling, you know, one of these at a time. So let's start off with this one, which is relatively simple. It's probably the simplest one, which is just requesting subject data. Okay. So basically what we would like is that when we start our experiment, for example, I don't know, something appears on the screen saying, what's your name, your age, and your gender, something like that. We can then save that data at some point when we finish our experiment. So when we have the data of the participant, we also have the data of their name, their age, and their gender. It's all in one convenient package. So where do we start off from? Well, let's start off by just, you know, Googling this. You know, let's just look for MATLAB get user input, okay, on Google. So you're just going to do that. So I'm going to go here. So I'm going to write MATLAB get user input. Okay, so the first thing it takes me to is here. So MathWorks, this is the company that developed MATLAB. So the fact that I'm finding a function in here is telling me that this is an inbuilt function into MATLAB. So that's good. Let's have a look at what this is all about. With this low connection, of course. All right. So basically, we're talking about a function that's called input. This is the name of the function. So the syntax is basically how you would write this function, okay? And typically the way this works is that you have a function, input. In this case it's called input, but it could be called anything. And in parentheses, you provide some inputs to that function, okay? So the input to this function, which happens to be called input, it's just a coincidence, is a prompt. Now prompt, here it explains what it is. It's just basically some text, okay? Just some text. So some text that we're going to provide with a string. All right. So basically, we just write a string in here, which is then going to be displayed on the command window. And on the other side, you have the output of the function, which is basically whatever the participant responded. Okay. So conveniently here you have. So when you're looking at a function, you're going to have some basic idea of how to write it down. That's what syntax means. A description of what it does and what its inputs are, for example. Okay. And conveniently, there's also some examples. So this is actually the part that's, you know, most interesting to us, because here's, for example, it's showing you the function, okay, and the prompt. Okay. So what's actually going to be displayed on the screen, which is a string of text. You can see it's a string because you have the apices here. Okay, so why don't we try working with this? So we can try this out. Why don't we try opening the editor and creating a new file. So I just clicked on the plus sign and it created an untitled project here. Okay, I can actually save this as something like, let's call it test input. Okay, test input. Okay, so let's just grab something from this example. So I could just grab this. Okay, so instead of keeping prompt here So specifying prompt as a variable here and plugging this variable in here. I'm just going to write directly the text in here just so it's a bit more compact. So I'm just going to write between APCs, I'm just going to write some text. Actually, input some text. Okay. And I'm leaving a little space. Now, if you notice in the example, the syntax, there's two options here. Okay, one is basically just going to prompt some text, and it's going to expect an input, and the input is going to be like a number, for example. So, for example, it could be, "What's your age?" However, there's another option here where there's this APC's S. Okay, and that basically is for requesting text inputs. So basically, if I'm asking the participant to insert some string of text, I'm going to need this extra S over here. So I'm going to do that, because if we're requesting the name, for example, we might, we're going to expect some text. Okay. So if I just run this, okay, in my command window, I'm going to see a prompt that says input some text, and if I click here, I can just input some text. Okay, so it's going to store it as an output, which is X. Okay, so basically we covered one first aspect that might actually help us, for example, to request a participant name, or for example, a participant gender. So let's actually start customizing this a little bit. So our output is stored currently, our output meaning our response, the response to this question, input some text, is stored as a variable X. Let's give it a name that's a bit more suitable for our purposes. So let's say name, subject name, is equal to input, and instead of writing input some text, let's just type your name. Okay. We're going to leave it as a string because we want the name is going to be a text string. Now what I'm going to also do is I'm going to add a semicolon at the end. The purpose of the semicolon is basically that it makes sure that when I run this line here in my script, MATLAB won't immediately provide me basically with the output. So basically what that means is this, that if, for example, you saw, for example, at the beginning we created a variable called A and we stored a 1 in it. If I just press enter, MATLAB is automatically going to show me what's inside A. If I do this and I write a semicolon after it, MATLAB won't return anything. Basically, A still exists, I still assign a value to it, but MATLAB is sort of, just silently accepting it. It's not providing me feedback that A is equal to 1. I have to actually manually now type it in to see what is contained inside A. Because obviously, in a script I'm going to end up with maybe, several lines, in which I'm assigning something to a variable. I don't want to see every single assignment in my command window when I run my program. Okay, so just as we used input to request a participant name, we could use the same thing, for example, to request the participant gender. For example, I'm just going to copy this line. I'm just going to change the name of the output to gender, okay? And I'm going to change the prompt, the text prompt. I'm going to say your gender. Okay, since we're at it, at this point we can also request, for example, a participant age. Now, the difference here with respect to these other two conditions is that we're not going to be expecting some text. We're going to be actually requesting a number. So obviously I'm going to change here the name of the output, but I'm also going to make sure that instead of I just erase this S that was requesting for a string. So basically the input that we accept is now going to be just a number. And I'm going to write your age. Okay. So we can actually try running this. So if I just click on run, I get my first prompt, which is going to be stored as name, which asks me your name. I write my name, my gender, and my age. Okay. So currently, remember, because we put the semicolons, we suppressed the outputs. But you know, if I just type the name of each one of my variables, so if I actually look in here, I have a variable called name, I have another one that's called gender, I have another one that's called age. If I type name, well, you can obviously already see the values for each one, but let's just write it in the command window. If I type name, it tells me the output. It's Nicola. If I type gender, male, you know, age, 39. Okay. One other thing we can do if we want to get a bit fancy is, instead of keeping these outputs separate, so just having one variable called name, one variable called gender, another one called age, we could basically associate all three of these outputs to or store them in a bigger variable. So for example, we could have a variable that's called subject. And this type of variable would be called a structure, where basically we specify different parts of that variable. If, for example, just like if the subject were, you know, I don't know, a person. It has a head, it has arms, it has legs. And to add these different components, what we can do is just by adding a dot. So if I add subject.name, basically we have our variable subject, and one of its components is called name, and this is what's stored inside of it. We can have another component of it that is its gender, okay, and this is what's going to be stored in it, you know, the input of the question gender. And we can have the last one, the last component, which is age. So I'm going to run this just so you see what this looks like. So I'm just going to type in the same thing as before, Nicola, male, and 39. So if I just now type subject, I'm going to notice that subject contains three elements: a name, Nicola, a gender, male, and an age, 39. So all these three elements are associated to this bigger variable called subject, which is called a structure type of variable. Okay, so basically at this stage we have all the ingredients that are necessary for this first goal that we had. That was basically get some way of requesting participants to, you know, input their name, their age, and their gender. You know, something relatively straightforward, but that's going to be definitely useful in our experiment. So let's go to the second of our list, of our laundry list here of ingredients, which was present stimuli. So present stimuli. Now, we talked about two types of stimuli, in essence. You know, the first one was actor images. So we're going to have in our folder, you're going to see. Actually, I'm going to show you. We have. So I'm going to click here on the tab Current Folder. Okay, and you can actually see what's inside the current folder, which in my case, this is where it's on my system, but of course, on these are going to be the files that you're going to download from the Microsoft Team file page. And you're going to notice that there's two images in this folder. One is called F1, one is called F2. If I actually open these outside of MATLAB, so if I right-click, open outside of MATLAB, you're going to see it's just a picture of an actress. Okay, so that's one type of stimulus, so images, which we're going to have to, you know, somehow get into MATLAB and instruct Psychtoolbox to, you know, display on the screen. And the other type of stimulus that we were kind of thinking that makes sense to include is some text. You know, that might be anything from, you know, a greeting card to something at the end of each block saying, what's your response? Does this feel too short? Does this feel too long? You know, it's useful to have some text here and there. So this is basically now where we're going to get our feet wet with the Psychtoolbox, because it's more specifically about displaying things, and as we know, Psychtoolbox is that's what it's for. So why don't we start off by looking at demos, okay? And let's start with text, actually, because text is probably going to be easier than pictures. So I'm going to go back here, and I'm going to Psych demos. Right. Okay. So in Help Psych Demos, we saw that there was already some stuff related to text. I'm going to have a look at the draw formatted text demo. Okay, so I'm going to click on it. I already had it open, but anyway. Okay, so actually I have to open it by draw formatted text demo. Okay, so actually I'm gonna go down here and write open draw formatted text demo. Okay, it's here. Okay, now here's a brief description of what it does. So basically, in a script, whenever you see things that are followed by an asterisk, by a percentage sign, and they're in green, it basically means that these are just comments. So basically, when the program is running, when MATLAB goes through the script, it's not going to try to run all the stuff that's in green. It's just going to run all the other stuff, and the stuff that's in green is just there, so you can leave yourself a note of what something does, or you can leave some instructions on how the script works or what it's supposed to do. So obviously there's a lot of things going on in here, but we should sort of like just have a quick look, and based on the description, see if we can understand what's going on. So a first thing that you already know, because we talked about it, is the fact that there's a basic blueprint for pretty much any script in Psychtoolbox. So there's some, as I said, some stuff that's related to variables or clearing. But the thing I want to draw your attention to is the fact that in Psychtoolbox you will eventually open a window, okay, on which you're going to be displaying screens. You're going to be doing some stuff like presenting stimuli over and over again across trials, and then eventually you're going to be closing this window. So you're going to be, these are generally called open screen and closed screen. So if I look for that in the screen, in this script, I'm actually going to come across instances in which I open a screen. Open window with default settings. Here it is. So here you're opening a window. Okay, open window. Okay. Eventually, I know that I should expect this window to be closed at some point. So if I keep on scrolling, it's probably going to be towards the end. Okay, I get end of demo, close window. Here it is. Okay. So those are two. We know that those are two ingredients that are, the basics. They're going to be there in any script. There's probably going to be other stuff that's related to, instead of text, because we're interested in displaying text. So there's text stuff going on over here. So like specific text font style and size. That sounds promising. That sounds relevant. But if we keep on going down, read some text file. Now we were really not interested in that because we don't want to display, like text that's loaded from somewhere. We just want to write something simple like respond now or something like that. So I come across this function over here down here, which just says draw formatted text. Okay, so that sounds pretty self-explanatory. It's just a function that draws some text. Okay, so for the moment we identified already a few useful things. We identified a function to open the screen, to open a window on the screen. We identified the function to close the window, which happens right about here. And we identified some candidate function here for drawing text, draw formatted text. There's other stuff that's related to drawing text, but I'm just going to draw your attention immediately to this one over here because it's just a bit simpler to use than this one over here. So I'm going to just tell you this from the start. Basically, when you're in Psychtoolbox, so when you're drawing something, you won't immediately see it on the screen. It's a bit counterintuitive because when you have a function that's called draw, you're assuming that you're instantaneously going to see something. That's not exactly how it works. The way it works is basically that when you're drawing something, it might be text, it might be some geometrical shape, it might be just changing the background color. This change has occurred in what's called an off-screen buffer. Basically, it happened on memory. In order to actually change the display, you have to update the display. It's basically just like refreshing, a browser page, for example, after some changes occurred in the background. And the way you do it is with a function called flip. Okay, flip is basically a way of sort of refreshing the monitor and updating it so you can actually see things that have been drawn in the background. Okay. So we identified these four elements. So why don't we start actually picking these things apart, so we understand how they work and how we can, modify them to suit our purpose. So let's open a tab in the editor. We can save this as, let's just call it test display text. Okay. So let's just grab some of those lines. So I'm going to grab this one over here to open the window. I'm also going to copy the comment, just so I sort of already have some recollection of what it was about. So I'm going to open the window. Fine. Yeah. Push this back. Okay. So since I did that, I'm immediately going to grab the function for closing the window, because I know that eventually I'm going to have to close it. So end of demo, close the window. Okay, so I got that sorted out as well. Okay, then I'm going to grab the draw formatted text line over here. And I'm going to put it somewhere in between. Okay. I'm going to change the wording here because this is more generically just about drawing text. Draw text. I'm going to write in parentheses just so I remember. This is off screen. Okay. I'm writing that because remember, I'm not going to see it until I flip. So I'm going to grab the flip instruction as well. Screen flip. Okay. And I'm going to write flip screen to see the text. Okay. So the last thing I'm just going to grab from that script is you're going to notice that all these lines of code are encapsulated inside these lines here, starting from line 14, which says try, and ending over here, where you have this condition is called catch, and this is where the whole thing ends. Basically what this means is try running all the stuff that's in here. Okay. If something doesn't work in here, if there's an error because there was a typo, because you know, for ABC there's something that crashes the script, then try running this bit here. Now what this bit here does over here in this instance here is it closes the screen, because remember that Psychtoolbox, you're opening a screen, but if it's, for example, full screen and you have a crash, then you end up with you know, an open window that you don't know how to close. So if there's a crash in this part of the script, you end up here, you close the screen, and you display in the command window what went wrong. Okay, so this is basically a safety net, and we want that. So what I'm going to do is I'm just going to copy all this bit here. I'm going to go here. So I'm going to write up here try. I'm going to just tab all these things so they go forward, just so it's easier to visualize. Not because it changes anything in terms of how this executes, but it's just more, okay. Okay, so basically we're going to try running this, ideally. If something fails here, we're going to close the window that we opened, and we're going to display the error. Okay. So we have to start understanding what's going on. So we have the basic ingredients. If I were just trying to run this, it wouldn't run, because probably wouldn't run because I just copied and pasted a few lines, and there's probably some variables that haven't been properly set up. For example, my text hasn't been specified anywhere in here. It probably was specified somewhere in here. You can actually see where variables come from, because if I click on a variable, you see it highlights all the instances in which that variable appeared before. So for example, I know that my text was initially set to some value, which was actually an empty string. Okay, so we have to basically pick these lines apart to understand what's going on. So when we start understanding how to open a window, for example. Okay, so open a window. So how do I know how to use this? Okay, so the way you do that is when it comes to functions that come from Psychtoolbox, you would go over here in your command window. You type the name of the function. So screen is the broader umbrella of functions that are related to screen operations, such as drawing, rectangles, arcs, or opening a window, or flipping. Those are all functions that relate to a larger function called screen, okay? But the more specific function that you're trying to do is the one that's actually written like this, between these single quotes. When you want to get some help about how to use one, basically what you do is you just add a question mark right after the name of the function in here. Okay, so I'm gonna do that and close the parentheses. Okay, and I'm gonna press enter, and it's gonna give me a very, very long, description of how to use this thing. A little bit convoluted, but let's try to follow it. Basically, it's showing me the syntax. This is how you would write it. So one thing to keep in mind is that some of these things are without a bracket. Some of them have a bracket. Okay. The bracket basically is telling you if things are optional or not. So, for example, here there's no bracket, so I know that this variable here, this input, is going to be required. And here I have a bracket, so I know that these ones, all the ones that follow, aren't required. They have some default values, so you can just leave them empty. So basically it's saying, how do you use this? You get screen is the name of the function, and more specifically what you're trying to do with screen is to open a window. Okay, so open a non-screen window. Specify a screen by a window pointer or a screen number. So this input here, basically what you're providing them is the number of the screen on which you want to open the window. Okay, so you're opening a window. Now, if you're doing this on a laptop, you only have one screen, your monitor. But what if you have, like, for example, a monitor that's plugged in to your laptop? You might want to open the window there and display the stimuli there. So this is where basically we indicate on which screen we're going to be opening a window. Let's do it on the primary screen, which is just 0. So we have screen, open window. We have a screen number, so let's actually write 0. Okay, and then we have like some other parameters. So you have like the color. As I said, this is a default value, so I'm just leaving it empty. But I'm following that with another input, which is this one over here, rectangle. Rectangle is just a way of specifying the screen size on which, how big the window will be. So I'm setting these numbers here, 001280800, because I don't want the window to open in the full screen. So basically, if I only had this, it would be absolutely fine. Just that the window would occupy the full screen. But unfortunately, that won't, if I then run it that way, the software I'm using to capture the video won't be able to record it. So I'm just leaving these extra lines over here, okay? You can do the same, and it's gonna open a window, essentially, a small window. Assuming your resolution is smaller than, is actually bigger than this. So if this doesn't work, just erase these lines over here, and just keep it like that, and you're going to be absolutely fine. So what is this open? Basically, what is this output? Sorry. So the output, remember, is what's on the left side of this equal signs, of the equal signs of any function. So the output basically is just the name of the window that I've opened, just so I can then, when there are other things I want to do on that window, I want to draw other stuff, I know what it's called. I know how to, I can instruct Psychtoolbox to do things with this specific window. So because it's a bit abstract, I'm just going to give it a more, obvious name, like my window. I'm just going to call it like that. Okay, so I opened a window, and I called it my window. Okay, it's on my primary screen, the only screen I actually have attached to this computer. I'm not specifying any background color, but I am specifying the size of the window, how big I want it, okay? Okay, so next thing, draw formatted text. So let's see how this one works. Okay, so we can look it up. So we go here in the command window. I just cleared it. And I'm going to type help, draw formatted text. And I get a long description again. But let's see. So draw formatted text, again, here's the syntax. This is the name of the function. Here are the inputs. So this is an input which does not come in brackets, so you know that you have to specify this, whatever it is. We're going to see in a second what it is. You need to specify this other input, tstring, and these other ones are optional. All right. So let's try to understand what they mean. So the description, it draws a string of text t-string into Psychtoolbox window when. Okay, so basically it's telling you we're going to draw a string of text. So we have to specify in t-string a string of what actually we want to display, what text we want to display on the screen. And we're going to draw it on the window that we've opened. Okay, so up to there, it's pretty simple. So basically what we're going to do is, instead of having my text, I'm actually going to write, between single quotes, I'm just going to write some text on the screen. Okay? Now, I am going to draw it on a window. Which window? The one that I opened before, the one that I opened. So it's called my window. So I'm going to copy my window and I'm just going to plug it in here. Okay? So the other parameters, sx, sy, those are basically locations, okay, where you would be writing it. So for example, center, center. So basically center horizontally, center vertically. That sounds absolutely fine. I'm just going to leave that like that. The other one would be the color of the text. 0, I'm going to assume it's black. Generally 0 is black and 255 is white. But there can be variations. Sometimes 1 is white, so you have to sort of like read out the text. But anyway, definitely 0 is going to be black, and I'm absolutely fine with that. Okay, so flip. Let's have a look at how this works. So this is, remember, because this is a Psychtoolbox screen function, if I want to see how to use this, what I have to do is I just copy this into the command window, but I add a question mark here. Okay, and then I close the parentheses, press enter, and it explains me how to use screen flip. It's basically just saying, oh, all you have to do is, okay, so let's read the description. Flip front and back display surfaces in sync with vertical retrace and return completion timestamp. This is just a very complicated way of just saying, just update the display. Okay, so we're able to finally see what we drew. All right, so the only thing you have to provide, you see that it's full of things that are in square brackets. The only thing you have to provide is the window that you want to update, the screen that you want to update. And so we're going to always provide the name of the window that we opened. Okay. Finally, we close all. Okay, and when we finished displaying, okay. Now, just consider one thing, that remember, the when we press run, okay, MATLAB is basically going to run through this script sequentially. So the first thing it's going to do is going to open a window, then it's going to draw some formatted text, then it's going to update the screen, so we're going to be able to see the text, and then it's going to close the window. Now the only problem is that it's going to do these things in this specific order, which sounds fine, but the problem is that it's going to do it as fast as it can. So basically, when it comes to the stimuli appearing on the screen, they're just going to appear there for a fraction of a second. We won't be able to see it. So I'm just going to insert an extra line here just to stop the script for as much time as I want. So there are many ways in which I could do this. I could just tell MATLAB to wait some time, and that would be a function called wait seconds, like that. And you just specify in parentheses how many seconds, like 1 second. So I'm just going to write that down. But I commented it because that's not what I'm going to do. So I'm just going to write here, I could wait 1 second. Or what I'm going to do, or I could wait for a key press. So in that case, it would be, I think it's keyboard wait. Yeah, keyboard wait. So basically, keyboard wait is just a function that when the program reaches this point here, so it's executing the things one line at a time, but when it reaches this point, the program stops on this line until a keyboard event has been recorded. Then it keeps on going. So let's save this and let's run it. So I'm going to press on run. So as you can see, a window just opened and some text appeared on the screen. Okay, so I'm just going to press now some key, and I should expect this thing to close. That's exactly what happened. Okay, so at this point, basically we already learned a few key things, that are really going to help us in the next few steps. So we learned basically that when you're using Psychtoolbox, things are generally going to happen inside a window. So you need to open this window. You need to close this window at some stage. And things are going to happen in between, right? You're going to eventually present some stimuli, which basically is going to involve generally some drawing, okay? And we're then going to have to display them actually on the screen in order to visualize them by issuing a flip command, okay? We also saw, however, that these things are going to occur they're going to occur sequentially, but as fast as the machine can process them, So we're going to need something to control some of the events. So we actually used this keyboard wait instruction, but we could have used wait seconds instead. So instead of actually expecting us to press a button, we just would have, we would have seen the text on the screen for one screen, and then the screen would have closed. So basically, we covered, one component of our sub goal of presenting stimuli, which was presenting text stimuli. So obviously now we're just presenting, some random text, like some text on the screen, but this could be something like, press A if this or that, or else, press L, something like that. So we can use this as a way, for example, at the end of the trial, to tell the subject, press this button if you feel that the stimuli was too short, or press this other button if you feel that the stimuli was too long. So we already have this key ingredient in place. So let's see what's next on the laundry list. Well, we have display pictures, right? Because in our experiment, the main thing, the actual experimental stimulus is going to be still frames of an actress, looking down and looking up. So we have to understand how to actually grab these pictures and display them in Psychtoolbox. Okay, so now the question is, where do we start from? So we could have a look at the demo list. However, if you actually scroll through that list, there's nothing that specifically mentions figures. So let's just look online. So let's look for, let's just Google draw picture Psychtoolbox. Let's see what comes up. This already. Okay, so basically what we come up is conveniently some Psychtoolbox pages that they start referencing things that seem pertinent, like draw texture, put image, make texture. So let's open one of these. So Psychtoolbox is really powerful software, but the documentation tends to always be a little bit hard to parse. So here there is, let's see if the description helps us in any way. Convert the 2D or 3D matrix, image matrix, so it's talking about an input called image matrix, which is right over here, into an OpenGL texture and return an index, which may be passed to draw texture to specify the texture, which basically means give me a matrix, okay, which is a MATLAB matrix, which represents something related to the image, and create a texture, and the output is going to have a name, texture index. It's going to have a number or an identifier of some sort. I can then pass this one to another function that's called draw texture. So it's basically telling us that make texture and draw texture sort of work together. And as a matter of fact, we saw draw texture over here. So that's fine. We see that there's something here of potential use. Given, however, that this documentation is a little bit hard to understand, let's actually look for an example. So what I'm going to do is I'm just going to copy this part over here, and I'm just going to write this example, right? Okay, the first place it takes me is this page over here, okay, on GitHub. So this seems like something very, very useful, because it starts off by saying, this is just it's basically a little script, okay, that says, opens a window using Psychtoolbox, shows simple examples of usage of a number of drawing commands. So basically it's just going to go over a long list of drawing commands. So, obviously there's a lot of stuff going on here, but we already are starting to grow a little bit accustomed to some, typical functions to expect in a Psychtoolbox script. So for example, there's a function here to open a screen. Okay, so if we have this one, you already know what to expect towards the end, something to close a screen. As a matter of fact, here it is. It's the last one. So here it's doing various things related to drawing stimuli. So you see a lot of screen commands. So the screen command, for example, that we used two of them. We used one to open the screen. We used this one when we wanted to display some text. We also used the screen command to flip the screen, which was to actually display what we drew on the off-screen buffer onto the monitor. As you can see, there's also a wait command, and we kind of know why that's there. That's there because, as in our script, when we drew something, when we drew some text, okay, here it's actually drawing some oval shape. Then we flipped, and then we waited for a keyboard press in order for the program to sort of wait on that position until we decided to move forward with a key press. This is the same, in concept, the same thing, just that in this case it's actually just using a timer, essentially. It's waiting for a duration, which is a variable specified over here. Our duration is equal to 1, so it's waiting for 1 second. Okay, and what is it doing? It's going to draw an oval, it's going to fill an oval, okay, so it's going to actually fill it with some color. It's going to draw a rectangle. I'm just guessing these based on the name because I already know some of these functions, but in some instances you can sort of work it out just based on the name. You can fill a rectangle, draw a line. Okay, so a lot of things that you can build millions of stimuli just by using these instructions here. Draw lines. Okay, so draw a line, one line, several lines. Okay, draw arc, fill poly. Okay, we don't need any of these, but this is a really good collection of draw instructions for any experiment, really. Okay, but here is where the interesting bit comes. First of all, there's some stuff related to text. So actually, when it was here, we have some further examples of how to use text, just like we get it in our sample script. Here, however, it says, note, with textures you need to first make them and then draw them. This sort of reminds us a little bit of what we just saw related to that make texture and draw texture help pages that we found previously on Google, on the previous Google search. So it sort of seems relevant to that. As a matter of fact, we see make texture. This is where we see it first appear, okay? And we also see a draw texture command. It's over here. And the other thing you notice is that, for example, there's this variable here, im2, which mentions a PNG file. Now, PNG file is a type of image file, just like that. It can be, you have a BMP, a PNG, etc., etc. So this example seems to be of relevance for what we need. Okay, so what we can do is we can now start, why don't you start picking this apart? So let's do essentially what we did last time. Let's start moving some of these things into the text editor and try to figure out, one instruction at a time, what's supposed to happen. So I'm not going to copy everything because there seems to be some repetition. As you see, there's two images. There's an im1, which uses this function here, which generates some random numbers. And im2, which instead seems to call a PNG file, which seems more relevant to whatever we're trying to do. So I'm going to start off just by copying this line because it seems somewhat, more pertinent to our problem. I'm just going to copy this line. So I'm going to go here. I'm going to open a new tab on my editor. I'm going to save this file as we can call it. Let's see. I'm going to call it test display. I don't know, image, something like that. Okay. So I'm going to copy this line over here, but I'm going to start actually copying also some things from my previous script. For example, I'm going to copy the try catch bit because I always want that safety net in place. So I'm just going to remind you that the try catch bit is there. So let me just paste this. I'm just going to move this one, scoot this one forward just so it's a little bit more clean like that. So the purpose of this was try to run whatever's in this area here. If this crashes for A, B, or C, run whatever's happening here. And what is happening here is that you close the screen, so we get back to this, setup here, to this display, and display on the command window what went wrong. Okay, so we definitely want this as a sort of a starting place for all our things. Okay, so let's just go back to the web page. Let's see what else we can grab here. So there's something related to the PNG. We still don't know exactly what this does, but you know, there's a PNG mentioned. So there's an image file that supposedly, probably we're just going to be loading it like this. But we're gonna, meanwhile we saved this bit. Then we found something that talks about make texture. Okay, so make texture seems relevant. I'm just going to copy one of these. Now, if you notice that there's two of them, because there was actually two images, IM1 and IM2. Okay, just for consistency, because I grabbed IM2, I'm just going to grab the second one, which talks about IM2 down here. Remember, don't be concerned about the fact that we still don't exactly understand what's going on, but we're sort of like working this out based a little bit on logic, on the fact of our previous Google search, where we saw that the first two things that came up when we looked for, you know, display, image, and Psychtoolbox, the first two things that came up were two screen functions. One that was called make texture, and then the one was called grab texture. So we're sort of grabbing that stuff. All right. So I'm just going to plug this in down here without worrying too much yet about what it is. I'm also going to grab this draw texture command. I'm always going to grab the second one because it references a texture 2. All right. And what else? Well, there's a flip command because, again, you're drawing something. First we were drawing text in our previous example. Now you're drawing a texture, okay? And as usual, what you're doing is drawing does not mean that you see it instantaneously. You will not see it on the screen until you flip, okay? So I'm going to copy this part as well. Okay. Now, I also know one thing, that after I've displayed, so I'm just going back to my test display text.m file that we worked on previously. And if you remember, after we flipped, what we did is we waited, right, on the screen for a certain amount of time. So I'm going to just copy this because I know that this is going to happen. This is going to be required. So I'm just going to plug this in. And I also know that I have to close the screen. So I could copy this one, but I'll just give you a little tip. You can do the same thing by just typing SCA. It's the same thing. It's just a shorthand for close the screen. So close screen. Close. Okay. So you could. I wrote this one, but of course, if you just wrote screen close all, it's the same identical thing. The same thing is going to happen. All right. So I'm not going to try running it yet because I still have to understand what the hell's going on, right? Okay. So let's reverse engineer this a little bit. So try to understand what's going on. Let's look at IMRead. What is IMRead? So I'm just going to look for IMRead. So IMRead is not a Psychtoolbox function. It's just an inbuilt MATLAB function. And the way you generally look up a help file for that is just by typing help and the name of the function. All right. So it's a pretty long description. So let's just try to see if we can immediately understand what's going on in the first few lines. So in IMRead, read image file from graphics file. Read image from graphics file. All right, so this seems basically, I'm just going to write up here, read image from file. Okay. So let's see how it works. So this is the syntax. So this is the name of the function. These are its inputs, file name and format. And this is the output. All right, so let's see what these means. So it reads a grayscale or color image. Good. We already know that we have an image and we know that it's a color image from the file specified by the string file name. Okay, so we have to give it a name. So the name that's specified here is t.png, which in the case of that example, I'm assuming there was a file called like that. We have no t.png, but we do have our images which are called f1.bmp and f2.bmp. The second one is the format. It's written over here at the text string. FMT specifies the format of the string. Okay, so the format would be, you know, whatever format this is specified in, which is BMP. So I'm just going to do that. So basically, I'm going to write f1.bmp, and here I'm going to write just BMP. Okay. So I'm gonna, because I don't want to run the script because it's probably gonna crash if I just run it. I'm just gonna run this line. So I'm gonna just copy this. Okay. And I'm gonna paste it inside the command window. Actually, the other thing no, let's just do it that way. Okay. I'm gonna press enter. Okay, and something happened. Now remember, because I added the semicolon, I don't see the output. Okay, I don't see the output unless I request it. Now the reason why I left the semicolon, I was about to take it off, is because the output is going to be rather large, but I'll just show it to you so you can see how large. Okay, so it's pretty big, right? I just pressed Control-C to stop presenting, the output. So basically, this is the last line we had, okay? To see the last lines is just up arrow, okay? Another little trick is, for example, if I, for example, start typing something and then I press up arrow, it's going to show me all the instances in which I specifically started a line with with that string of text. Okay, so basically what I've done is I've used IMRead to load an image called F1BMP. Now F1BMP is saved inside a matrix. Now if I go into my workspace and I look for IM2, here it is, I know that it's a matrix. It's a rather large matrix. Now it's not going to be as easy as visualizing E that we created in the last lesson. If you remember, we had a matrix that was called E, which was this, right? Because the main difference here is that IM2 has several more rows. So while this one has 2 rows, this has 720 rows. It has several more columns. This one has 3 columns, whereas IM2 has 1,280 columns. But IM2 also has a 3rd dimension. So basically, IM2 is a volume. It's like 3-dimensional, and basically you have. So think of it like the way I think of it is like, imagine that you have an Excel sheet which is 720 rows and 1,280 columns large, but you have 3 of them and they're stacked one on top of the other. Okay, that's how you can think of the 3rd one. Okay, so you have 3 spreadsheets, one on top of the other. Now why do you have 3? You have 3 because IM2 is a color image, and files, let's say color files, generally are specified according to 3 different primary colors, which are red, green, and blue. So basically you have an image for red, an image for green, and an image for blue. They're stacked one on top of the other. Okay, so don't worry too much about these details. The bottom line, just where I want to get to, is that currently IM2 simply is a matrix with some numbers in it. Okay, just so you have an idea of what's actually inside IM2, I'm going to show you a subsection of what's in IM2. So I'm not going to show you the whole matrix because it's a very, very large matrix. I'm just going to show you a little snippet. And the way I'm going to do that is through indexing. So if you remember last time when we talked about indexing, we were talking about vectors or matrices and the fact that you can request the contents of an array or a matrix at a specific location. So for example, if I have a vector that's like this, 1, 2, 3, I can ask MATLAB, what is contained at location number 2? He's telling me, at location number 2, you have 2. If I have a matrix, I can do the same thing, but I have to be, well, I can be a bit more specific, because now I have rows and I have columns. So I have rows 1 and 2, and I have column 1, 2, and 3. So the way you ask this question when you're dealing with a matrix, it's always with a round bracket, but you'd be saying, what is in row number, and you specify the row. So let's say, for example, row number 2. And column number, let's say column number 3. So you basically first specify the row, and then you put a comma, and then you specify what column. So what's in row number 2, second row? Column 3, it's 6. Okay, so if I press enter, it says 6. Okay, so I'm going to do the same identical thing with IM2. But instead of just showing one value, I'm going to show more than one value. So another thing you can do, for example, always with E, is I could request, for example, values that go from that are within a certain range. So for example, I could ask, Tell me, okay, always row 2. Row 2 is fine. But I want to know what's in columns 1 through 3, which happens to be all my columns, but anyway, column 1 through 3. So with this symbol, with the semicolon, I'm just telling him, go from 1 up to 3 in steps of 1. So 1, 2, 3. Okay, so if I press this, it's basically going to give me second row and all columns, so 4, 5, and 6. Okay, so I'm going to be doing the same identical thing with IM2. So I have IM2, I'm going to request, I don't know, I want, for example, the first, let's say 2 rows, the first 3 rows, whatever. Let's do the first 3 columns. So rows 1, 2, and 3, columns 1, 2, and 3. And remember that IM2 is 3-dimensional, so I also have to, I'm just adding an extra comma and specifying on which one of these 3 stacked, let's think of it, sheets do I want you to do this search. Let's say on sheet number 1. Okay. So if I press this, it gives me some values. So what these values actually represent is basically a value, an intensity level for each pixel that corresponds to this image. So this image is actually an image made out of several pixels. It's actually 720 times 1280 pixels. And each pixel has a specific intensity level. Now basically what happens is that these intensity levels can be translated into an image. That's basically what's happening. So I'm going to show you this to you with a function called IMShow. IMShow does just that. Basically IMShow, you just give it a matrix, which is just a collection of numbers. Remember, IM2 is just numbers. It's just numbers. And translates it into an image. So I'm going to give it as an input IM2. Okay. And I press enter, and as you can see, we have an image. Okay, but this image has been converted just from numbers. Okay, and remember that each number, now you're only seeing 3 by 3 here, but it would have been, because I just requested the first 3 rows and first 3 columns, but technically you would have the number of pixels that correspond to each single pixel in this image, okay, which has various rows and various columns. All right. Okay, so we sorted out this first part. So where we're reading an image from a file. So basically we are specifying an image, which in this case is F2BNP. We are loading it into MATLAB and storing pixel information about this image into IM2. So IM2 by itself is just a collection of numbers, but we saw that we can easily translate that into an image that then we can actually put on the display. So what we're going to do is look at the next step, which would be this make texture. Now, if you remember when we had a look on Google, it already mentioned that there was basically a step in which you would be making a texture based on an image that you had loaded, followed by drawing a texture. So let's look at this function here, make texture. So what we're going to do is we're just going to copy this into the command window, and we're going to add a question mark over here, just so we get some help about it. Okay, so as usual, we get a lot of text, which can be a little bit hard to parse. But just by looking at the syntax, we sort of get the hang of what's going on over here. So this is the name of the function, screen make texture. Okay, all clear. Its purpose is that of converting a 2D or 3D matrix, image matrix, into an OpenGL texture. Okay, so basically it's taking a 2D or 3D matrix, which is called image matrix, in the sense that this is one of the inputs of this function, image matrix. Okay, so it would be referring to IM2, because IM2 is a matrix that we've produced by reading this image file, by importing this image file. Okay, so you provided this image matrix, and this function here, make texture, creates a texture, okay, that permits you then to visualize that image. Okay, so it clearly requires image matrix. We know that because it doesn't come within, it's not encapsulated in brackets. And the other thing that is required is the window index. So remember, this is just, we already saw this more than once. We saw it every time. As a matter of fact, we use a screen command. Every time when we open the window, we saw it. We saw it when we we flipped, for example. So we're telling it on which window to perform the screen operation. So basically, we can just, we already see there's the repeating pattern with respect to our previous script. So in the previous script, for example, we had, here's, for example, our flip command, right, screen flip. And as you can see, also this one was pointing to a window. And it was the window that we opened here. So the thing that's missing here, in this script here, is that clearly we didn't open nor close a screen. So we have to do that. So let's actually do that. So I'm just going to grab the open window line from my test, display text, and I'm just going to plug it here at the beginning. Okay. The line to close the screen was already there, so we have forgotten I had forgotten to include this one, but now it's there. Okay, so so basically, let's get back to this line here. So we know that this, based on this brief description, basically on the first few lines, we just know that this line here is about convert a image matrix. I'm just going to write in parentheses that I'm referring to IM2 to a texture. Okay, so that's what it's doing. So actually, IM2, you know, for the moment, it's kind of an arbitrary name. We're going to change it a little while. We're going to give it something that's a bit more relatable to the actual content of the stimulus. F1BMP. I'm just going to open it up so you can see what it looks like again. Is a face looking downwards, you know. So we might at some point just change this name just to reflect that. Okay, but just to keep track of this number, this variable that's moving throughout. Okay, so what it spits out, the output of this. So remember, this is the function. These are the inputs, and this is the output. Texture index is specified here, and returns an index which may be passed to draw texture. Basically, what it's saying is that it spits out a name, an identifier, a handle, whatever you want to call it, that through which you can recognize, you keep track of this texture. So then when it comes to drawing it, you know which texture to draw, because you might have loaded 50 textures, for example, and you might then want to only draw a subset of those 50, for example. So in this case, you know, there's a name here with a parenthesis. I'm just going to erase this parenthesis because it was pertinent to the example on the web page. But over here, I'm just going to write texture. Okay. And I'm also just gonna update this name right now because it only appears in these two instances, so I might as well just change it now. So I'm just gonna say face down, and I'm gonna say matrix. Okay. So I'm just gonna copy this here. Okay. Okay. Then okay. So then the next line over here. Draw texture. So let's see what this one does. So I'm just going to do the same thing as I did for make texture. So I'm just copying this lines here. I'm going to my command window, and I'm just pasting this and adding a question mark, like that. Okay, and I'm pressing enter. Again, a very, very long description, but this is what it does. It basically draws the texture specified via texture pointer. So it's basically saying, this is the bit that we definitely need. The rest is, let's say, just if you want to be more specific, there's a lot of, you know, additional things that you can specify. So window pointer, he's just talking about on what window do you want to draw this texture. Okay, so that it's something. It's always the same thing. It's the window that we've opened, my window. Okay, and by the way, here we have to update this. So it's the same thing as for made texture. Also here, there's a window pointer. So I'm going to actually plug in the window that I've opened. That's called my window. Okay. And here I have the same thing. So I'm going to provide a window pointer, which is on what screen essentially we're doing this. Okay. It's on my window. And then the texture pointer. So that's basically the handle of the texture that we've created, which is called texture. This one here. So I'm just going to plug this one here. I'm going to erase things that follow because that's all we really need. So just based on the description, draws the texture. That's really all we need to write here. So it's draw texture. So we draw the texture, but remember, you're not going to see it until you flip. I'm just going to remind myself about this. Flip to display on screen. Okay. After that, we're waiting for a keyboard press, and then that's it. So let's just go over this and make sure that we're happy with it. So the first thing we're doing, we're opening our window. Okay, so we're actually opening the window on which we're going to be displaying things. So remember, if we're opening it, we're going to be closing it eventually. So let's just make sure those two things are covered. Okay, so when we opened it, we gave it a name. So we said, okay, this window that you're opening, just let's call it my window. Okay, and let's just keep track of that. The second thing we did is we loaded an image file. So we used the imread function to do that. So we loaded a bitmap called F1 bitmap, and we stored it inside a matrix called face down matrix. It's just, you know, a matrix with a lot of numbers in them, representing the values, the intensity level for each pixel of that image. Then we're using screen make texture. We're specifying to convert this image into a texture. So we're specifying what window, on what window we want these things to occur. Okay, and it's my window. And we're specifying the name of the matrix that contains the pixel data. So we create, and we're storing this. We're providing it a handler. We're giving it a name. This texture is, we're just going to call it texture. But we can actually be a bit more specific, and we can call it like, let's use the same name that we used here. Let's just call it face down texture. Let's be more specific. So remember, I updated it here, so I'm updating it also in here. Okay. In draw texture, we're actually drawing the texture that we created. So again, we specify on what window we want this to happen. So it's my window. And the texture that we want to draw. So we're actually pointing the actual texture. Okay. So it's what we ended up having in the previous line over here. Finally, okay, we want to see it. So we flip the screen. We flip. Oh, and here there's an error. The window, because remember also when you're flipping, you're providing the name of the window, okay, and we called it my window, so to make sure that it's called like that. We flip, then we wait, okay, we wait for a keyboard, because or else if we just let it run, the script will exit instantaneously. We're not even going to see the image, even if it was displayed, but just for a fraction of a second. And when we finish, we close the screen. Okay, so I'm going to save this, and I'm going to run it. Okay, so I see the image, it's been loaded, it's been displayed, and currently it's there because it's waiting for me to respond. If I now press a key press, okay, it closes, and that's that. Now, since we're dealing with two images, so if we just go back to, you know, our sketch of the experiment, we're going to need two images. We're going to need this image, which we currently, or no, actually I think we loaded this one now, I remember, because F1, no, so we loaded this one here, looking downwards. We're going to also need this one that looks up, okay, so we might as well just, you know, try to do that, try to incorporate this in the script, because it seems like a natural extension of it. You know, we're still tackling the problem of displaying an image, so let's just expand this a little bit, because we're still in that, you know, ballpark. So what I'm going to do is, okay, so I'm just going to open the window, that's fine. Okay, so read image from file. Now, currently I'm reading one image, but I could just read another image right over here. So what I'm just going to do is I'm going to copy this line, paste it here, and now I'm just going to create a new matrix, which is face up matrix, and I'm reading F2. Okay, so this should work. Okay. Okay, we convert images to textures. So currently I was talking about IM2. Here, that's the old name. So I'm just going to actually write this one and this one. So remember that these are just comments, so you know we remember what we did. You know, we can then easily figure out what was the reason for certain steps or the way we wrote some things. Okay, so basically I'm going to need two of these. So currently I have face down texture, and it's all this make texture thingy. So I'm just going to copy this, and I'm just going to do the same identical thing for the upwards, the up gazing face. So face up texture, it makes texture, this is fine, it's still my window, yeah. But now it's loading a different matrix file. It has to be face up, right? Okay, so then it's drawing. So let's think about this. So here, I can't simply take this and then copy it again and change up. You know, I could be tempted in doing that because that's essentially what I did in all the steps, all the previous steps. But that's not the correct thing to do because let's think about what would actually happen. So here, I'm loading image 1 and I'm storing it, its pixel data, into a matrix. And I'm doing the same thing for face 2, right? F2. I'm just storing it inside another matrix. So these are two separate matrices. Now you can do these one after another because it doesn't really matter. It's, you know, they're not actually displayed yet. They're just loaded into MATLAB. Here I'm creating textures. Again, I can do these two things one after the other because I'm just creating textures. I'm not actually displaying anything. But in here, when I'm drawing, now here order matters because remember that the idea here is that you want to actually display on the screen. So you have to put them on the screen and they have to stay on the screen and you have to be able to appreciate it on the screen. It has to be there for a sufficient amount of time. If I just did this, what's going to happen? It's going to draw the first texture, which is the one looking downwards. But remember that I don't see things until I flip. Remember? So if I draw this first, I won't be able to see it because it's off the screen for the moment. Then it's going to draw this one on top of it. And when I finally do flip, so things appear on my monitor, it's going to be the last thing I drew. So that doesn't work. That's not gonna work. So what we need is basically to draw and flip twice. For the first texture first, and for the second texture after that. So let's say draw texture 1, flip to display on screen. So I'm going to keep these two close together. Okay. Then I'm going to just copy this. I'm going to copy both of these. I'm going to make a little bit of space so we can visualize these things a little bit better. Okay, so draw texture 1. So I'm drawing the first texture. I'm flipping it on the screen. Drawing the second texture. So let's make sure this is face up. And I'm flipping it on the screen. Now remember, however, that another thing we have to do is we have to wait a little bit because if we draw it and flip it, it's true, it's going to be on the screen, but only for a fraction of a second before it draws and flips the next image. So let's make sure even our keyboard wait is there. So let's move this one over here. So let's do it like this. Okay, perfect. There you have it. So we're drawing texture 1, we're flipping it, so now we can actually see it on the screen, and it stays on the screen until I press the keyboard button. Then, as soon as I press the keyboard button, it draws the second texture, flips the screen so I can actually see it on the screen, and then it waits for a keyboard press. After that, it closes. So let's try running this. So we have the first image. It's waiting for me to press. I press, and the second one, and it exited very, very quickly. So the reason why it exited very quickly is because it's true that there was a keyboard wait here, but the problem is that between the time I pressed this keyboard button, okay, and the time it took it to draw the texture, flip the monitor, so to actually display it on the monitor, and then start waiting for a second button press, I was still holding the button down. I was still holding the button down because the events between this button release and this one is still just a fraction of a second, and it takes me a few hundred milliseconds to let go of the key. So in order for that not to happen, what I'm going to do is I'm going to actually introduce right after this line another line which waits a little bit of time. So it enables me, it allows me to the time to let go of the button. So I'm just going to do that with a wait seconds. So if you remember, I mentioned wait seconds, I think over here. I didn't use it, but I mentioned it. So these are like the two main ways for controlling the time events. Waiting for a certain amount of time, or waiting for an event to actually happen on the keyboard. All right, so I'm going to wait for, we don't need to wait a lot, we can wait for half a second, so I'm just going to wait 0.5 seconds. Okay, so now you're going to notice that when I save this, I'm going to run it. Okay, so it's waiting for my keyboard press. Okay, something happens there. And then we exit. Okay, so let's go back to our document over here. Right, so we managed to sort out our text. You know, we created a little script for that. We called it test display text, in which we learned, you know, the basics of opening a window, closing a window, the fact that we're assigning a name to this window, because all screen functions, all Psychtoolbox functions then generally point towards this window, because Psychtool wants to know on what screen should I perform that draw, okay, or that whatever, that flip, okay. We managed to, you know, just print some very, very simple text on the screen, which is all we really need, because we might need an experiment, you know, just like a little prompt for the participants to know when to respond. And we figured out, just by looking a little bit online and doing a little bit of, you know, reverse engineering, ways to load images into Psychtoolbox, transform them into textures, and draw the textures. And all these things, as you can see, I mean, they were sort of like hacked a little bit. It's not really about, you know, learning the whole thing from scratch and then start to programming. It's literally starting from the program to identify the problem from the start and then work backwards from there. And Google tends to be, you know, a very, very, it tends to be a great tool for this. So related to stimuli, so we covered the important ones, text and pictures, but, you know, another one that I included here, but it's really not essential for this experiment, you know, could possibly be, for example, some way of, for example, changing the background color. This might be, for example, a way to, you know, separate in a more stark way trials by, you know, separating each trial with a background that changes color or something like that. So I'm not gonna go into the details of this, but for example, if I were interested in doing something like that, and I go back to the document that we were looking at before on Google, you know, there's a function here that can be of use to doing that, which is basically the fill rectangle function, which basically what it does is just that it draws a rectangle and it fills it with a color that you specify. If you look up the help file of this, you start it starts to become very familiar. I mean, you just have a screen and the name of the function, the window on which you want to do this. We called our window my window. I think this should be the color that you want to use. This would be middle gray. So, you know, because 0 is black and 255 is white, so that's about halfway in between. And these would be the rectangle coordinates, how big this rectangle should be. If you just omit this rectangle, so if you just have up to here, this rectangle is essentially going to occupy the whole screen. So it could be, for example, a rectangle, you know, that's a black rectangle that occupies the full screen, and you can sort of use this as a sort of a blank screen across trials or between stimuli, just to separate stimuli. So this covers pretty much all the things related to the presentation of stimuli. In the next, let's say in the next lesson, we're going to go one step further, and we're going to start talking about the flow of events. But I'll stop here and see you in a bit.